We're going to start today by talking about the reciprocal identities. So far, we have learned that sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. All the problems we've done have given a value for sine, so to find cosecant's value, we just flip it. For example, if the sine of theta equals 4/3, the cosecant of theta would equal 3/4. So when you're given values for your trig functions, keep doing what you've been doing. If you need to use an identity, you're going to use it like you would use substitution in algebra. So if I tell you that x equals 7 in algebra, you're going to substitute in a 7 anywhere you see an x. You could use the reciprocal identities to substitute in for sine 1 over cosecant. For cosecant, you could substitute in 1 over sine.
Lucas Hutchinson, come to the main office. Lucas Hutchinson to the main office, please.
Sorry for that interruption. The cosine of theta is the reciprocal of secant, so whenever you see in a problem the cosine of theta, you could substitute in 1 over the secant of theta. Secant could substitute in 1 over the cosine of theta. Tangent and cotangent are reciprocals, so if you see tangent of theta in a problem, you could substitute in 1 over the cotangent of theta. And if you see cotangent, you could substitute in 1 over the tangent of theta. Now again, don't use these if you know the values, but if you don't know the values, then it might be helpful to use these identities. The quotient identities allow us to continue substituting in values. You guys have learned that tangent is equal to y over x. Well, if the y value is sine and the x value is cosine, tangent is also sine of theta over cosine of theta. Cotangent is the reciprocal of tangent, so if tangent is y over x, which we now can say is sine over cosine, then cotangent would be x over y, which is the cosine of theta over the sine of theta. So anywhere in a problem where you see a tangent of theta, you could now replace it with a sine of theta over cos of theta if it would help you solve the problem. Now let's talk about the Pythagorean identities. The three Pythagorean identities that will always be given to you are these three that are in the boxes. So let's fill those in. Sine squared plus cosine squared equals 1. 1 plus tangent squared of theta equals secant squared of theta. And 1 plus cotangent squared of theta equals cosecant squared of theta. Again, these three will always be given to you. So now in a problem, if you ever see sine squared plus cosine squared, you could replace it with a 1. Identities are used like substitution. If you ever see a 1 plus tangent squared of theta in a problem, you could replace it with a secant squared of theta. If you ever see a 1 plus cotangent squared of theta, you could replace it with a cosecant squared of theta. It's also helpful to use algebra to rearrange these identities. So if I were to subtract cosine squared from both sides, so I'm looking at the first identity, sine squared of theta plus cosine squared of theta equals 1. If I were to subtract cosine squared from both sides, then sine squared of theta would be equal to 1 minus cosine squared of theta. If I were to go back up to the original identity and solve for cosine squared, then I would have to subtract sine squared from both sides. So I would know that cosine squared of theta equals 1 minus sine squared of theta. So that means that I can replace cosine squared of theta in any problem with 1 minus sine squared of theta if I need to. If I needed to solve for 1 in the second Pythagorean identity, I would subtract tangent squared of theta. So 1 is equal to secant squared of theta minus tangent squared of theta. In the second Pythagorean identity, if I needed to solve for tangent squared, then I would subtract 1 and I'd get the tangent squared of theta equal to secant squared of theta minus 1. So again, I use these identities to substitute. Anywhere I see secant squared of theta minus tangent squared of theta, I can substitute it in for a 1. On the third identity, if I wanted to solve for 1, I would subtract cotangent squared from both sides. So 1 would equal cosecant squared of theta minus cotangent squared of theta. If I needed to solve for cotangent squared, I would subtract 1 from both sides. So cotangent squared of theta is equal to cosecant squared of theta minus 1. So what I've written in here will never be given to you on a quiz or a test. You would have to take the 3 that were in the box and rearrange those in your head to be able to come up with the ones that are written down below. Okay, so let's see where these Pythagorean identities are used. In this next example, we're given that the sine of t is radical 5 over 5 and the cosine of t is 2 radical 5 over 5. Well, when we learned the unit circle last class, we learned different values for x's and y. We also learned that the sine of y, or the sine of any value on the unit circle, is the y value in the point. The cosine of any angle measurement on the circle is equal to the x value on the point. There's no x value of 2 radical 5 over 5, and there's no y value of radical 5 over 5 that you guys have to memorize. So that means this problem is not giving us values off the unit circle. So if we can't use the unit circle to solve a problem, we need to use our new identities. So if I look up at my identities, I know that the tangent of theta is equal to the sine of theta. Whoops, sorry. I had my highlighter turned on. The tangent of t is equal to the sine of t over the cosine of t. That's a quotient identity. So if I put the sine of t, which is radical 5 over 5, over the cosine of t, which is 2 radical 5 over 5, and I simplify this, my 5's will cancel because they're both denominators, and mathematically when I multiply by the reciprocal, those 5's would cancel. So that leaves me with radical 5 over 2 radical 5. The radical 5's will cancel, and that leaves me with 1/2. So the tangent of t in this problem is 1/2. If tangent and cotangent are reciprocals, then the cotangent of t is 2 over 1, which is just 2. So you don't have to use your identities every single time in a problem to solve it. Once you find the value, 1/2 is the value for the tangent of t. Once you find the value of the trig function, then you can just flip that value to find the reciprocal trig function. So let's do that using secant. Secant of t is the reciprocal of cosine of t. So if the cosine of t is 2 radical 5 over 5, then the secant of t is going to be 5 over 2 radical 5. I'm fine if you guys do not rationalize your denominator, but the back of the book probably will rationalize, so your answers might not match up. The cosecant of t is the reciprocal of the sine of t. So again, I'm not using my identities because I have a value for sine. So if I have a value, all I have to do is take the reciprocal of that value to get the reciprocal function's value. Let's move on to the next example. On the next example, we're given that the cosine of t equals radical 10 over 10. We're also told that t is greater than or equal to 0 and less than pi over 2. That tells us that we are working in quadrant 1. Quadrant 1 on the unit circle is in between 0 and pi over 2. So a lot of times in your directions, it'll tell you what quadrant to get your answers from. All we're going to do on this problem is find the value of the sine of t using a trig identity. Well, the trig identity that we're going to use is the one that has only sine and cosine in it. I guess it also has a 1 in it. But I'm picking this Pythagorean identity to use as opposed to the quotient identity tangent equals sine over cosine, because if I use the quotient identity tangent equals sine over cosine, then I would be bringing in a third trig function, which is tangent, and I don't want to do that because mathematically it would get harder if I bring in more trig functions. I know that the cosine of t is radical 10 over 10. I need to solve for the sine of t. So what I'm going to do is I'm going to substitute in radical 10 over 10 for the cosine of t. But since this is a Pythagorean identity, radical 10 over 10 has to get squared because cosine is squared in the identity. So from here, I can just use algebra to solve. The square root of 10 squared is 10. 10 squared is 100. If I reduce that, I get 1/10. So now if I subtract 1/10 from both sides, I get that the sine squared of t is equal to 1 minus 1/10 is 9/10. And now just like you did in algebra, if this were x squared equals 9 over 10, you would take the square root of both sides. You can do that with trig, and you know sine squared, or the square root of sine squared is sine. T is the angle. It just always stays with the trig function. The square root of 9 is 3, and the square root of 10 is radical 10. Normally in Algebra 2, when you take the square root of both sides, you would include a plus or minus in your answer. We only want positive answers because we are working in quadrant 1. In quadrant 1, everything is positive. So sine is equal to the y value. The y value is positive in quadrant 1, so we only want positive answers. We don't include the minus with this. If you guys are confused, it usually takes a few days to get all of these in your brain and to process it and to make it make sense. So don't freak out on day 1 if you don't quite get it. But I will recommend that you come in to see me during STAR or study hall to get some extra help. Okay, so let's move on to the next one. If I want to find the exact value of the expression, well, to find the exact value of the expression, you're going to use your identities or you're going to use your unit circle. If you're using your identities, your angles have to be the same. So when I'm looking at my angles here, they're both 18 degrees. So that really doesn't matter. As long as they're both the same, I can use my identities. So I'm going to look at my identities and figure out which identity has a secant squared in it and a tangent squared in it. And it's the second Pythagorean identity that's listed. So that is 1 plus tangent squared equals secant squared. Forgot the thetas. So I need to make that identity look like secant squared minus tangent squared. I can replace the thetas with 18s. So what I need to do here is subtract tangent squared from both sides. And I can see that secant squared of theta minus tangent squared of theta equals 1. Well, if I let the thetas be 18 degrees, I can also see that the secant squared of 18 degrees minus the tangent squared of 18 degrees equals 1. So if I'm using my identities like substitution, I can replace this problem with a 1. If you recognize that without showing work, go for it. If you need to show all that work for your thought process, that's fine too. On the next one, tangent of pi over 3 times the cotangent of pi over 3. Well, you know tangent and cotangent are reciprocals of one another. So if you leave the tangent of pi over 3 alone and you use your reciprocal identities to rewrite cotangent as 1 over tangent, then you can see the tangent of pi over 3 cancels and you're left with just 1. So in part A, we used a Pythagorean identity. In part B, we used the reciprocal identity. You're using both identities like substitution in algebra. So in part C, we're going to use the quotient identity. And we're going to replace sine over cosine with tangent. Notice all of the angles are 20 degrees, so I'm going to leave the tangent of 20 degrees alone, and I'm going to substitute in for sine of 20 over cosine of 20, another tangent of 20. So sine of 20 over cosine of 20 is equal to tangent of 20. That's what the quotient identity allows us to use. So then the tangent of 20 minus the tangent of 20 is just 0. On part D, since we're given tangent squared and we're finding secant squared, I'm going to go back to my Pythagorean identities, and I'm going to use the Pythagorean identity that says 1 plus tangent squared of theta equals secant squared of theta. We're told in this problem that the tangent squared of theta equals 8. So wherever you see a tangent squared, you're going to substitute in an 8. Then you just do the math. 1 plus 8 is 9. So 9 equals secant squared of theta. That's what you're trying to find, so you stop. Using the identities will become, I guess, more familiar to you the more you do it. So the more you do it, the better you're going to get. Okay, now let's switch gears back to our unit circle. Let me scroll down here. If I want to find the exact value of each trig function, but I can't use a calculator, that means I'm going to have to go back to my unit circle. So I'm using my unit circle for these problems as opposed to my identities. I'm actually probably going to use a little bit of both. Okay, so I need to find where 9/4 pi is on my circle. I know 9/4 pi is on my unit circle because the denominator is a 4. On the unit circle, all your denominators are 6, 4, 3, or 2. So I think it's helpful to draw a sketch. 9/4 pi is the same thing as 2 1/4 pi. So remember, one rotation is 2 pi. So if you go an extra fourth, that's going to put you into quadrant 1 right here. So you have to decide what point is that on the unit circle. So that point is radical 2 over 2 for x and radical 2 over 2 for y. Just move that 2 1/4 pi down. So now to find cotangent, you've got to realize that cotangent is the reciprocal of tangent. So if tangent's y over x, then cotangent is going to be x over y. So if cotangent's x over y, then you're going to take the x value, which is radical 2 over 2, and you're going to put it over the y value, which is radical 2 over 2, and you're going to reduce it. So the cotangent of 9/4 pi is equal to 1. Remember I talked about last time when you're finding tangent or cotangent, you can always ignore the denominators because the denominators will always be 2 and they will always cancel out. So technically you just have to take the numerator of the x, which is radical 2 over 2, and put it over the numerator of the y, and then reduce. Okay, cosine of 5/2 pi. You know this is on the unit circle because the denominator's a 2. So you've got to figure out where 5/2 pi would be located on your circle. Well, every 90 degrees is 1/2 pi. So this would be 1/2 pi, 2/2 pi, 3/2 pi, 4/2 pi, so 5/2 pi is right here. So that point on the unit circle is the same as the point pi over 2, so that's the point 0, 1. So you've got to figure out where your angle is going to be located on the unit circle, and then the points you've memorized on the unit circle don't change. So you just have to figure out what point value you need to look at to find your answer to your question. I know cosine is equal to the x value at that spot, and the x value at that spot is 0. So the cosine of 5/2 pi is 0. Now let's talk about secant. Well, first of all, as soon as I see secant, cosecant, or cotangent, I change it to its reciprocal. So secant is the reciprocal of cosine. So I'm going to find the cosine of negative 3/4 pi first. And then once I find that answer, I'll take its reciprocal, and that'll be the answer for what I'm actually looking for in this problem. So I'm going to go to negative 3/4 pi. Well, negative 3/4 pi, I have to go in a clockwise rotation. Positive 3/4 pi is in quadrant 2. We talked about last time how all the angles on the unit circle, if they're reflected over the x-axis, would be where their negative angles would be. So positive 3/4 pi is right here in quadrant 2. If I reflect that over the x-axis, that puts me right here, hang on there, right here for the terminal side of the angle in quadrant 3. So this is negative 3/4 pi. That point is negative radical 2 over 2 for x and negative radical 2 over 2 for y. So cosine is the x value. So the cosine of negative 3/4 pi equals negative radical 2 over 2. So if secant is the reciprocal of cosine, then secant's going to be negative 2 over radical 2. And you can leave your answers unrationalized. Okay, next we have the sign of negative pi over 4 minus 1,000 pi. First of all, the minus 1,000 pi just means that you're going to go around negative 1,000 revolutions on your unit circle. Remember, all even numbered pi's end up being over here. All odd numbered pi's end up being over here. So since 1,000 is even, negative 1,000 is going to end up over here. Since it's negative, you would have gone in a clockwise rotation. So now you have to just go negative pi over 4 more. So that's going to put us right here. Any denominator that ends in a 4 is going to have an x value of radical 2 over 2 and a y value of radical 2 over 2. But since this y value is in, or since this point is in quadrant 4, the y value is negative. So now you just have to look at the point and you have to realize that sine is equal to the y value. So the y value of that point is negative radical 2 over 2. And that's your answer. So a lot of this is just getting used to certain spots on the unit circle and memorizing the points that go with those spots and being able to find the x value, the y value, or the y over x value. Let's move on to cotangent. If I want to find cotangent, then I would find tangent first. Technically, I really don't find tangent. I know, and I've memorized, that tangent is y over x, so cotangent is going to be x over y. So I know my answer has to end up being negative because of this negative right here. So I'm going to make sure that I stick that negative right there. So if I can find the x value and the y value, I just have to make sure I stick the negative in my answer, and I will be able to complete this problem. So I got to figure out where I need to go on my unit circle. Well, 17 is odd, so odd numbered pi's go over here, always. So I need to go an extra fourth. So an extra fourth is going to put me right here into quadrant 3. Well, the denominator's a 4 again, so that point in quadrant 3 is negative radical 2 over 2 for x and negative radical 2 over 2 for y. So cotangent is the x value over the y value. So if I put negative radical 2 over 2 over negative radical 2 over 2, that's going to reduce to negative 1. I do realize that when I put negative radical 2 over 2, because again, when I told you guys when you find cotangent or tangent, you ignore the denominators. So when you put negative radical 2 over negative radical 2, that does reduce to a positive radical 2. But remember, our final answer has to be negative because of this negative that's located outside the cotangent in our problem. So our final answer is just negative 1. So let me clean up that answer so it looks a little bit better. Moving on to our last few problems. If I want to find the value of theta in radians and degrees, first of all, I'm finding the value of theta, so I'm working backwards. All the other problems so far, I've been given the value of theta. I find that spot on the unit circle, and I either give for an answer an x value, a y over x value, or their reciprocals. Now I'm working backwards. I'm giving you the value, so I'm giving you the x, I'm giving you the y, or I'm giving you the y over x, and you're telling me what theta needs to be. So you've really got to look at your unit circle. You know cosine is equal to the x value. So you've got to go to your unit circle and you've got to find where the x value is equal to radical 2 over 2. Well, your x value is equal to radical 2 over 2 right here. And your x value is equal to radical 2 over 2 right here. So sometimes you're going to have more than one answer. So if I'm looking at my unit circle, those angle measurements are at pi over 4 in quadrant 1 and 7/4 pi in quadrant 4. If I look at cosine's value is positive radical 2 over 2. You have a positive x value in two different quadrants. So that's why we have to have two different answers. Our directions officially say give our answers in degrees and radians, so that would be 45 degrees or 315 degrees. So now let's look at tangent. You have to remember tangent is equal to the y value over the x value. So since tangent is equal to a fraction, this value that's actually given has probably been reduced. So where on the unit circle can you take the y value over the x value, reduce it, and get 1 for an answer? It's got to be somewhere that has radical 2 over 2 for the x and radical 2 over 2 for the y value. Well, that's got to be right here in quadrant 1, or if they're both negative, it's got to be right here in quadrant 3, because negative radical 2 over 2 over negative radical 2 over 2 would also reduce to 1. So that means our value for theta right here is pi over 4. Our value for theta right here in quadrant 3 is, let me give you a chance to look at it on your unit circle, 5/4 pi. The degree measures for both of those would be 45 degrees and 225 degrees. Normally you don't have to give me answers in both degrees and radians unless your directions state that. Okay, so now let's look at cotangent. Cotangent we know is the reciprocal of tangent. So if tangent's y over x, then cotangent is x over y. But this value has been either reduced or rationalized. So we got to go to our unit circle, and we have to remember that radical 3 over 3 is the same thing as 1 over radical 3. So that always has to be fresh in your head. Whenever you see radical 3 over 3, I almost recommend changing it immediately to 1 over radical 3. So you have to have an x numerator of 1 and a y numerator of radical 3 over 3. The values are both positive, so you have to think about what quadrant you're going to get your answers from. We're going to get our answer from quadrant 1, because in quadrant 1 we have a point at pi over 3. I'm struggling with my stylus right now, sorry. At pi over 3, your point is 1/2 and radical 3 over 2. So if I take the x value over the y value, remember ignore denominators when you're dealing with cotangent or tangent, you get 1 over radical 3, which would rationalize to radical 3 over 3. So one of our answers is pi over 3. The other answer is going to be in quadrant 3, because in quadrant 3, your x value and your y values are negative, so the two negatives would reduce to make